So let's say you just started using a new 3D scanner. Maybe you bought the cheapest one Amazon had available. Maybe you started a new job and they already had a scanner. Or if you're lucky, maybe you purchased a nice new system from GOM or Creaform. Whatever the case, it's always a good idea to figure out how accurate it is before putting it to work. So in today's video, we're going to demonstrate one of the many methods you can use to check the accuracy of your 3D scanner. Now, you might be wondering, why not look at the scanner's specifications and go off of that? Well, you could, but it's best to test it for yourself. On top of this, many companies typically don't list their accuracies in their promotional materials. It is pretty easy to find this information on most other types of metrology equipment, like coordinate measuring machines, but that's not always the case with 3D scanners. For instance, trying to find any sort of accuracy statement on GOM's website can be quite challenging, despite making some of the most accurate 3D scanners you can buy. As another example, the brochure that was distributed for the scanner I own also remains vague when describing accuracy. As you can see here, the scanner specifications are listed, but the only information on accuracy comes from this paragraph.
Delivering excellent data quality and highly accurate results, Comet L_ED is also ideal for demanding applications in quality assurance. The unique solution can even be combined with photogrammic processes to digitize large objects.
Okay. Maybe they will tell me the accuracy of my scanner after it's calibrated. Here's a calibration report produced by Zeiss's Colin 3D software. Let's see, we have the camera pixel, mean value, standard deviation, and maximum. Not sure what that means. We have the phase residuals, mean value, standard deviation, and maximum. Also not sure what that means. And then we do have a couple quality figures that are listed in millimeters, and I imagine that these probably correlate with the calibration panels that come with the system, but unfortunately I'm not really sure what they're measuring. But we do have some green bars on a graph. I guess that means we're good? Well, it's starting to become clear that I'm going to have to figure out this scanner's accuracy myself. And to be honest, I guess I do see where these companies are coming from. The truth is, the accuracy of any given scan is going to depend on a variety of factors. To name a few, there's operator skill level, lab temperature, vibrations, calibration, surface texture, color, part cleanliness. I could go on and on. So, before getting started, you will need one or more calibrated standards, which are also sometimes called calibration artifacts. These artifacts could consist of gauge blocks, calibration spheres, step height gauges, ring gauges, or any other calibration artifact you can get your hands on. The calibration standards I currently use most for 3D scanning are ball bars manufactured by Baltec. These ball bars have ceramic spheres on both ends that are an ideal color and surface finish for 3D scanning. They are separated by a bar made of an iron alloy known as Invar. This material has a low coefficient of thermal expansion, which will reduce contraction and expansion in environments that deviate from 20 degrees Celsius. Instead of just one artifact, I opted to get 3 because I have several sets of lenses for my scanner for measuring various sized parts. If your budget is low, I would recommend using a single white ceramic gauge block. Once you have your calibration artifacts, you'll need to make sure they have been calibrated. This process involves you sending the artifacts to someone else to have specific dimensions on the artifacts measured. But you can't just send them to anyone, you need to send them to a lab that does calibrations. I sent mine to Mitutoyo in Chicago. Measuring your calibration artifacts will establish something called traceability between your lab and globally recognized measurement standards. I'll talk more about this in a future video. When your calibration artifacts are returned, they should come with calibration certificates that list the measured values and the uncertainty of the measurements. You will need to know these measurements because you will be comparing the calibration lab's measurements against those you make on scan data collected with your own 3D scanner. I asked Mitutoyo to measure the diameter of both spheres, the distance between the spheres, and the form error of the spheres. Next, follow the scanner manufacturer's calibration procedure to ensure it is scanning to its maximum potential. This will require the use of the calibration artifacts that came with your scanner, not the calibration artifacts we will use to check the accuracy of the scanner. As an example, my scanner came with these calibration panels, and yours probably came with something similar. Once your scanner is calibrated, we can begin checking its accuracy. To do this, scan one of the calibration artifacts you sent off to be measured. Scan it like you would any other part so your results will be more representative of a normal scan job. Your process for your scanner is likely different from mine, so I won't go into the details on how to do this. Now that your artifact is scanned, it's time to take some measurements on the scan data. I accomplish this by exporting an STL from Calibration3D and importing it into GoInspect. GoInspect is a free application, and it's one of the best applications you can use for inspecting mesh files, even with the limitations of the free version. Regardless of what application you use, you will want to measure the same dimensions on your mesh that the calibration lab measured. In my case, I'm measuring the diameter of both spheres and the distance between them. In this example, I scanned my 11-inch ball bar using my 250mm lenses. Sphere A's diameter was 25.428mm, Sphere B's diameter was 25.407mm, and the distance between them was 279.556mm. I can then compare these values to the values in my calibration certificate provided by Mitutoyo America. But I don't just measure one artifact once. Instead, I like to inspect several artifacts several times to ensure my initial measurements weren't just a mistake. I keep track of all of these measurements in a spreadsheet that I periodically update. This ensures that I will catch any potential issues going forward. Once you begin compiling these results, you can begin to understand how accurate your scanner really is. Hopefully these measurements will confirm what you already suspected. If these measurements instead tell you that your scanner is very inaccurate, my deepest condolences. To provide further insight into my own process, I measured each of my ball bars 3 times with my 500mm lens set. I varied the number of scans and the scan settings from scan to scan. After plotting the results, I learned that my scanner is much less accurate when using the low-res setting, so I'll definitely be using the high-res setting exclusively going forward. When excluding the low-res measurements, I can start to see a trend of this lens set's accuracy. The maximum deviation I saw was about 30 microns for this lens set. So with continued testing and a larger sample size, this lens set's accuracy will probably level out at around plus or minus 30 to 40 microns. I will continue to do these types of tests periodically. As my sample size grows, the more confident I will become in using my scanner and knowing its accuracy. Before we end this video, a few additional things to note. 1. This process is really only a rough accuracy check. There are many more methods you could use to evaluate your scanner's accuracy. For instance, you could perform a gauge R&R, or you could estimate uncertainty for all of the measurements that you make. Unfortunately, I don't have time to go into details on these quality tools in this video. 2. Accuracy and resolution are not the same thing. If your scanner's manufacturer provides a resolution spec, your accuracy check results might be quite a bit different than the resolution specification. And 3, if you're interested in collaborating with Sentinel 3D scanning on an inspection project, make sure to check out our website. A link is in the description below.